Hi everyone, today I'm gonna present our paper on zero-shot attribute attacks in fine-grained recognition. Although neural networks are tremendously successful in different applications, they are vulnerable to adversarial examples. Adversarial examples are imperceptible noises that can be added to the input of a neural network to mislead it and result in a desired output. This lets the adversaries to take advantage when it comes to sensitive applications. The majority of the previous works focus on developing methods to deceive the coarse-level machine learning models such as GoogleNet, VGG, and Reason. Also, these approaches only consider cases where attacking happens with the same set of classes the model is trained and tested on, which is not the case in practice. Here in this work, we focus to develop an attack that is non-targeted, meaning that the perturbation should push the image X out of the boundary of the true class Y. Also, we assume that the adversary has access to the parameters of the model, and we directly define an optimization objective to find the perturbation. In addition, throughout this work, we generate image agnostic or universal perturbation that works on every sample of a specific class. Of image agnostic attacks, we can name UAP and gap, which are defined on the following setting. There should exist a class C with a score S more than class Y for the perturbed image I plus E. But these methods don't leverage the fine-grained information and attributes of each class. In this work, our contributions are as follows. We propose an approach to learning individual perturbations for attributes, and then composing these attribute-based perturbations to form class-level perturbations. The attack we propose is extendable to unseen or zero-shot classes, which is a more realistic scenario in deceiving machine learning models. The compositional attribute-based universal attack consists of three modules: universal generator, weight generator, and composition module. The first module generates one universal per attribute. Here, for example, the module generates one universal perturbation for red pill, one universal perturbation for black eye, and so on. The second module generates a set of weights per attribute given the text embedding vector of that specific attribute and the true class semantic vector. The third module gets the attribute universal perturbation and the corresponding weights, composing them, and then generates a class-level perturbation which can be applied to the images from the same class. Here is the loss function employed to train the attribute-based universal perturbations. The first term is the ranking loss, which penalizes if the prediction of the adversary example would be true. The second term is the regularization loss, to force the AUPs to be as small as possible. The third term is utilization loss, to utilize all the attributes instead of the dominant ones. This way, all the attributes participate in the CAUP attack. Here are the results of CAUP L2 norm attack on three different datasets, including CUP, animal with attributes, and sun. Attacks are compared in seen scenario, unseen scenario, and harmonic mean of both. The x-axis represents L2 norm of perturbation, and the y-axis represents the fooling percentage. Our attack has a higher fooling percentage compared to random perturbation, UAP, and gap in every case. Results on L infinity attack are also provided in the paper. These are 4 samples of attribute-based universal perturbation that were generated using our attack. On the right, adversarial examples from seen and unseen scenarios have been demonstrated. For example, the first image is from a fox spotter class, which ends up to classified as a spotted catbird after the attack. All these adversarial examples are semi-imperceptible to human eyes. Last but not least, to study the interpretability of our attack, we study the dominant discriminative attributes of each ground truth class. The ground truth class is presented in the middle, and the first 5 composition weights corresponding to the attributes have been queried. The figure shows that the dominant discriminative features of each class is playing an important role in perturbing that class. For example, in painted bunting class, attributes like purple forehead, red breast, and green wings are the ones whose their universal play a more important role in the attack. Thanks for the attention.